Hi, this is the lesson for 11.3 areas of polygons. Now, in your journal, this is on page 324. So before we start, we need to talk a little bit about some very important vocabulary that you guys need to know. So the first thing, let's talk about what is a regular polygon. A regular polygon is a polygon that has all of the sides on the outside are congruent and all of the interior angles are going to be congruent as well. Now, there's some other pieces of this that you guys needed to know. Now, every single regular polygon has what we call a center, which happens to be this one. Now, there are two segments that we're going to pay attention to. The first one is the distance from the center perpendicular to one of the side lengths. That length is called the apothem. Some people call it the apothem or apothem, it's the same thing. The other side that we're going to pay attention to is the distance from the center to the vertices of the polygon. Now that is not written on this paper, but this is actually called the radius. Now we are used to saying that the radius is the distance from the center to any point on a circle. But for this scenario, we can say that the radius is the distance from the center to the vertice. So radius and the distance perpendicular to the side length is called the apothem. Now what our goal is to find the area of a regular polygon. So what we're going to do is we're going to break this up into different types of triangles. So if you look at this polygon, for example, this is a pentagon. You can actually split from the center directly to each vertice, make a total of 5 different types of triangles that they're all going to be congruent. So for example, here's triangle 1, here's triangle 2, 3, all of this is 4, and all of this is 5. So if I find the area of 1, all I have to do is multiply it by 5. So let's focus on that, okay? So in this case, we're going to have 5 multiplied by the area of one triangle. Now, here's the thing. To find the area of the triangle, we have to remember what is the equation for the area of a triangle. The area of a triangle is 1/2 the base times the height. Okay, so 1/2. Now, in this case, we're going to let P be the distance from here to here, lowercase p, and the height in this case is the apothem. So we're going to change the H to an A. Now, I'm going to rearrange a couple of things here. Okay, now this is lowercase p. I should really make it look like a lowercase p. And there's a reason why the lowercase is going to matter. If I were to look at this and put them together, that's going to give me 5p times 1/2 times a. Now let's focus as to what exactly is 5p. If this length here is p, if this length here is p, 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 and p, 5 times p is the sum of all of the sides, which represents the perimeter. So 5p is actually the perimeter. We're going to use uppercase P for that. So this is the perimeter times the apothem divided by 2. Now, in some places, you might see the apothem first times the perimeter of the polygon and then divided by 2. Now, in the best case of scenarios, you will have the apothem, you will have the side length, and all you have to do is substitute values in here. But since this is not a perfect world, we're going to have a couple of struggles because sometimes they're not going to give me what this side length here is. They might tell me what this is, and what this is, and I need to find the apothem. So that brings us to the next challenge. Well, what kind of tools am I going to need in order to solve problems that require me to use that specific equation? Now, I'm going to scan this picture, and I'm probably going to see how I can attach it to the end of the video or send it to my students through Remind 101. So here are the three scenarios that you will encounter. We're going to practice using these as they arise. So the first tool, what is the first tool that you're going to use? Oh, forgot one thing, the central angle. By the way, this is the central angle right here. And when I'm referencing to half of the central angle, I'm only referencing to this little piece right there. So if half the central angle is either 30, 45, or 60, we are going to use the rules for special right triangles. And these are found in chapter 9, I believe lesson 2. Goes like this. In a 45-45, 90-degree triangle, the length of the legs are both the same and the length of the hypotenuse is x times radical 2. In a 30-60, 90-degree triangle, the short leg is equal to, is half of the long leg, and the short leg is half of the hypotenuse, and the long leg is the length of the short leg times radical 3. Nothing new. If two of the sides are given, then what you're going to do is you are going to use the Pythagorean theorem. Nothing new. A squared plus b squared equals c squared. This is in the case that you guys are not given a side length and the apothem. And then the third scenario that you are going to use is if half the central angle is not 30, 45, or 60, then you're going to have to use a trigonometric ratio, either sine, cosine, or tangent, whichever one is appropriate. Most of the time, you will be ending up with this angle right here, and depending on the information that you have will depend on what you're going to use. You might need to use sine, cosine, or tangent. So, going back to our first problem. Now we're still on page 324. Now this triangle right here, we're going to try to use that same equation that we just came up with, where the area is equal to the perimeter times the apothem divided by 2. Okay, so let's see here. This is an equilateral triangle. The distance from here to here happens to be 4. That means that because this is a regular polygon, this is 4 and this is 4. So that's easy. The perimeter is 4 plus 4 plus 4, which is 12. The only problem is I do not know my apothem. Now, to know my apothem, I kind of have to eyeball where the center is going to be at. And that's what I'm trying to find out. I'm trying to find out the distance from the center perpendicular to the side length. So I'm trying to find out what is this going to be. Okay, so I'm going to highlight it. What is that going to be? Now, what I'm going to do is I'm going to say that this is my center. I'm going to draw a line from the center to the vertex. So my goal is to figure out what is this angle right here going to be. So if I think about it, I can do this as well. This one's already like that. The whole central angle, you're going to find it like this. It's very simple. 360 divided by the number of sides that you have. In this case, it's 3. So I'm going to divide this by 3. Why 360? Because that's the sum of the angles all the way around. So 360 divided by 3. 360 divided by 3. That means that my central angle happens to be 120. But remember, this is the whole angle. I need only half of that. I need only this. So I have to divide it again. Okay? So another way that people can do this is they can do 180 divided by the number of sides. A lot of people like doing that. For me, I'm a procedural person. So if I were to divide this again by 2, okay, that's going to give me 60 degrees. That means that this angle right here is 60 degrees. So sometimes it gets a little messy. So I'm going to go ahead and redraw just this triangle right there. So this right here is 60 degrees. This right here is 30 degrees. And what I'm looking for is this, the apothem. Do I know this length? Yes, I do know that length. That length is half the distance. So if the distance is 4, that means the distance from here to here is going to be 2. So now I'm going to identify what tool am I going to use. This central angle here happens to be a 60-degree angle, which means that I'm going to use my 30-60-90 degree special right triangle rule. So I know that this is the long leg. So remember that the long leg is equal to the short leg times radical 3. So I'm just going to plug in the numbers. The long leg happens to be 2. The short leg, that's me at my apothem. I don't know what that is, but I do know that's radical 3. So now what I'm going to do is I'm going to divide by radical 3. Now I cannot leave my answer like this. So what I need to do is I need to rationalize it. So what I'm going to do is I'm going to multiply by radical 3 over radical 3. That's going to simplify, I'm going to put on the right-hand side, to 2 radical 3 all over, this is going to give me 3. So guess what? This right here is my apothem. That is what I'm going to put right there. Okay, so my apothem is 2 radical 3 over 3. Now, I want to know the exact area. And yes, I will be doing an approximation as well. So the area is equal to the perimeter, which is 12, times the apothem, 2 radical 3 over 3. And then I get to simplify it. Now, 12 times 2, that's 24. 24 divided by 3, that gives me 8. So my exact answer, it's 8 radical 3. Now, if they want an approximation, then all I have to do is just put it in the calculator. Square root of 3, then times 8. And that is going to give me approximately 13.9 if I round to the nearest 10th. Yes, it is a lot of work. Sometimes some problems will be pretty straightforward, and sometimes they're going to be very complicated. It all depends on what scenario you have. Now, let's jump into a bit of a different scenario. Okay, so in this scenario right here, let me move it over a little bit. Okay, we're going to look for the perimeter, and we're going to look for the apothem. The perimeter here, it's very simple because I know it's 4 on this side. So all the way around, it's 4. 4 plus 4 plus 4 plus 4 plus 4. That's the same thing as 4 times 5, which is 20. So now I need to find out what the apothem is. So I'm going to eyeball. That's going to go somewhere around there. I cannot say that's 2.8, 2.75. I really don't know. We have to figure it out. So the very first thing is I'm going to draw my triangle from the center to 2 adjacent vertices. Because what I want to do is I want to find out what this angle here is. So the way to figure it out is I like to find the central angle first. If you want to do 180 by the number of sides, go ahead. This is the same thing. So 360 divided by the number of sides, which is 5. That gives me 72. And then I divide that by 2. That gives me 36. So that degree is 36 degrees. Now the length from here to here is 2. It always helps if you redraw the triangle without all the other stuff. So this degree here is 36. This is 2, and I'm looking for the apothem. Remember, the apothem is the distance from the center perpendicular to one of the sides. Now, noticing that this angle is not 30, 60, or 90, that means that I cannot use a special right triangle. I have to use a trigonometric ratio. Now, I'm looking for the adjacent, but I know the opposite, which means that I'm going to have to use tangent. So tangent of 36 degrees is equal to the opposite over the adjacent. Now what I need to do is I need to solve for a. So I'm going to treat this like a proportion, put it over 1, cross multiply. I'm going to get a times the tangent of 36 equals 2. So I divide this by the tangent of 36, both sides, and a is going to be whatever 2 over the tangent of 36 is. Now, if they want the exact answer for tangent, for all that, you will be having to type all this in. So I'm going to divide it. 2 divided by the tangent of 36. This is approximately 2.75. Now, because I am using a trigonometric ratio, I'm going to use 4 decimal places. 2.75 and then 2.8. That's what my calculator's telling me. So now I know the apothem, and sorry I don't have that much space. The apothem is 2.7528. Now I get to actually find the area. Yep, we're not done. The area is the perimeter 20 times the apothem 2.7528 all divided by 2. Remember, the area of a regular polygon is the perimeter times the apothem divided by 2. So I'm going to multiply all that, 20, putting this in the calculator, 20 times 2.7528, enter, divided by 2. And I'm going to round this to the nearest tenth, and this is going to be approximately 27.5. So now you guys kind of get the hang of what's going on here. Okay, so here we have to use trigonometric. Here we have to use trigonometric ratio. Here we have to use a special right triangle. Sometimes, depending on the problem, you may not need to do either one. You might have to do Pythagorean theorem. It all depends on the kind of scenario that you guys are going to get. Okay, so I want to jump into the problems in just a bit. So I want you guys to go to page 325. And these problems, they're all done pretty much the same way. So due to timing, I'm not going to go ahead and do those. But there is something I do want to talk about down here. And it has to do with a kite. Okay. Now, if you remember, a kite is a 4-sided polygon that has exactly 2 pairs of sides that are congruent. It just happens to be that it's not a parallelogram. So in other words, this is congruent to this, and this is congruent to this. Now, back from chapter 7, we did learn that the diagonals are perpendicular to each other. Okay, so here's the thing. We're going to talk about the length of the diagonal. We're going to make this diagonal here. We're going to make that diagonal 1. Okay, so that diagonal right there. Now, the second diagonal is going to be the long diagonal. That one right there. We're going to call that diagonal 2. No, it's a little dark. Probably should use a lighter highlighter. Have green. Okay, so what we want to do is we want to find out what is the area of this kite going to be. Well, let's think about this. This is perpendicular, which means that this is actually a height. okay? So if all of this is diagonal 1, then only this part right here is diagonal 1 over 2, and this part is also diagonal 1 over 2. It's half of it. All of this is diagonal 2. So the area of a triangle is the base times the height. So the base happens to be diagonal 2, and the height happens to be diagonal 1 over 2. Okay, so the area is the base times the height, and then times 1/2. Okay, but here's the problem. That only gives me the area of the top. If I want the area of the bottom, I have to double this area. So I have to multiply this by 2. Why by 2? Because this right here only gives me the area of the top. If I want the area of the bottom, I have to double that area. So what does that do? That divides these two, which leaves you for the area of a kite to be, now I'm going to move the numbers around a little bit. I'm going to put the diagonal 1 first. Diagonal 1 times diagonal 2, all divided by 2. And that is the equation for the area of a kite. We're going to go ahead and move on to some of the examples. So please turn your journal to page 326. On 326, right at the top, you're going to do problem number 1 and problem number 2. Right there and right there. Problem number 3 is going to go down here at the bottom. Problem 3. Once again, the area of a rhombus or a kite with the following diagonals is 1/2 the product of the diagonals. And the area of the regular polygon, and example 4 goes there, is 1/2 the apothem times the perimeter. Okay. Now, some people like using this equation. To me, it gets a little complicated when people do that. So I like to use perimeter times apothem divided by 2. It's the same thing as this. Exactly the same thing. Okay. All right. Let's go ahead and jump into the examples. So here's the first example. Find the area of each rhombus or kite. Now, remember, the area of a rhombus or a kite is equal to the product of its diagonals, all divided by 2. So in this case, we need to find out what are those diagonals. It doesn't matter which one you call diagonal 1 or diagonal 2. This distance from here to here is 8 meters. So diagonal 1 is 8, diagonal 2 is 6. So to find the area, you have to again multiply the product, multiply the diagonals, 8 times 6, and then divide it by 2. So that's going to be 48 divided by 2. So the area of this rhombus is going to be 24 meters. Super simple. For the second part to this problem, identify the diagonals. Diagonal 1, 7, diagonal 2, 10. If you have them switched, it's just fine. So the area is 7 times 10 divided by 2. So then that's going to give me 70 divided by 2. The area is going to be 35 centimeters. If you need more time, make sure you guys pause the video so you guys have more time to copy. All right, let's move on to example number 2. Okay, so in this example, let me zoom in a little bit. It says in the diagram, by the way, example 2, well, I already told you where to go. It says that it's a regular pentagon. That means it has 5 sides. So they want to know each angle measurement. So the first one is angle AFB. That's AFB. That's this whole angle right there. That happens to be the central angle. So in order to find that, you have to do 300 divided by the number of sides. You have 1, 2, 3, 4, 5 sides. So we divide that. That's 360 divided by 5. That gives me 72 degrees. So this whole angle is 72 degrees. Now the next one is AFG. So to find that angle, you have to find this angle, which we already did, and then divide that by 2. So 72 divided by 2. And that gives me 36 degrees. So this small angle is 36 degrees. Now the next one is angle GAF. GAF, that's this one right here. Now this angle, if you remember, it's complementary to this angle, and this angle happens to be 36 degrees. So in order to figure that out, you have to do 90 minus 36 degrees. So when you do that, that's going to give me 54 degrees. Sometimes you're going to be using that angle rather than using this angle. So once again, the central angle, use 360 divided by the number of sides. Okay, this represents the number of sides. Can't see that. One second. Represents the number of sides. Then you divide it by 2 to find this angle right here. Let me use a highlighter to talk about which one I'm talking about. This little one right there. And then once you know that angle, subtract it from 90 to get 54. It's important for you to be able to work your way around a problem and finding angles. Sometimes you're not going to need all the angles, but sometimes you do. All right, let's look at example 3 now. Okay, example 3. This is a regular nonagon. It's inscribed in a circle with a radius of 4. Find the area of the nonagon. So first off, how many sides does a nonagon have? Well, let's count them. Okay, here you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 sides. Now we're going to need that. Now remember, the area of a regular polygon is the perimeter of the polygon times the apothem, all divided by 2. So here's the thing. Look at this polygon that you have right now. The only distance that you know is from the center to the vertice. You do not know this length, and you do not know the apothem. So we're going to have to do quite a bit of work to figure this out. So the very first thing we're going to need is we need to find out what this angle right here is. To find out what that angle is, I need to figure out what this whole angle is. How do I figure that out? Very simple. 360 divided by the number of sides, that's 360 divided by 9. That gives me 40 degrees. That means that half of that is equal to 20 degrees. So that means that this angle right here is 20 degrees. So I'm going to focus in only on this little piece right there. Okay, so let me redraw that. And that's 20 degrees. Now remember, the distance from here, from the center perpendicular to one of the side lengths is the apothem. So I need to find out what that is. Now I do know that distance from here to here is 4. So this is like L, K, and M, and this is going to be perpendicular. So my goal is to figure out what is the apothem going to be. Okay, so let's figure that out. Now here's the thing, you have the adjacent and you have the hypotenuse. The only trigonometric ratio that you can use that uses the adjacent and the hypotenuse is cosine. So cosine of 20 degrees is equal to the, sorry about that, adjacent over the hypotenuse of 4. So when you cross multiply, you're going to get the apothem equal to 4 times the cosine of 20. So 20 cosine, I'm using the calculator here, guys, times 4. Now this is only an approximation. And I'm going to approximate this. It doesn't say how much, so I'm going to put about 3.76. Now that's the apothem. Okay, that's only one out of the two things that I need. The next thing I need is I need to figure out what's going to be the perimeter. Now to find the perimeter, I need to figure out what is this going to be right here, the side length. I'm going to call this side length here x. Now once I find this side length, I have to double it in order to get the full length from here to here. Once I know the full length from here to here, all I have to do is multiply by 9, because there's 9 sides, and then I get the perimeter. So to find the perimeter, I need to first find out, well, I have 9 sides multiplied by the side length. By the way, that's an S, not a 5. Now, one of the things that I need to find out is what is the side length. So I'm going to figure out what half of that is. That's half of this. Now, I'm going to use sine in this case. The sine of 20 is equal to x over 4. So cross multiply, and you're going to get x equal to 4 times the sine of 20. I'm going to put this in the calculator. 20 times, actually, no, sorry, 20 sine, and then times 4. This is going to be about 1.37. So the side length, this whole side length is going to be twice of that. So what I'm going to do is I'm going to multiply that by 2, and that gives me about 2.74. Now, what am I going to do with that? I'm going to multiply this by 9, because that's what's going to give me the perimeter. So 9 multiplied by 2.74. And that's going to give me a perimeter of 24.6. So now that I know my apothem and my perimeter, I can find the area now. So here's what I'm going to do to find the area. Area is equal to the perimeter, 24.6, multiplied by the apothem, which is 3.76, all divided by 2. Okay, so then 24, put in the calculator, 24.6 times 3.76 divided by 2, I get the area of this polygon to be approximately 46.2. Now, if you're doing this on big ideas, if you put 46.2, it might be just a little bit off because of the rounding. So just keep trying like 46.1, 46.3, and it should be very, very close to that answer. Yes, this is a lot of work, I'm not gonna lie, but it is what it is, guys. All right, so let's look at example number 4. Okay, it says you are decorating the top of a table by covering it with small ceramic tiles. The tabletop is a regular octagon. Hint, hint. It has 8 sides with 15-inch sides and a radius of 19.6 inches. What's the area you are covering? So they're kind of nice because they give me the side length right here. So I know that the perimeter is going to be 8 multiplied by the side length, which is 15. So 8 times 15, that gives me 120. So the perimeter is 120. All I need to do now is I need to find what the apothem is. Now, if I were to draw the line from here to here, I know it's a little hard to see. Let me see if I can use a different color. From here to here, that's going to be the length of the apothem. Now, half of this distance is half of 15 because all these are 15s. So all this is 15. So half of 15 is 7.5. Now, if you think about this, let me clear it up a little bit. That length right there is 7.5. You know 2 of the side length. You know the hypotenuse and you know half of this. So you don't need a trigonometric ratio for this. You're just going to use Pythagorean theorem. That's the best thing to use. Could you use trigonometric ratio? Yes, you could. You could do that. Okay. You could find out what this angle here is and then use opposite over hypotenuse, and you know that would be sine. But why do a trig ratio when you do Pythagorean theorem? So I'm looking for the apothem, that one right there, the green one. I know it's kind of hard to see. But the apothem, quantity square, plus 7.5 quantity square is equal to the hypotenuse, 19.6 square. And remember, the goal is to find the apothem. Okay, so 19.6 square (7.5 square) okay, now you're going to subtract 56.25. Okay, so let me subtract this. 384.16, take away 56.25. That gives me 327.91. And then I take the square root of that to the nearest tenth. I get about 18.1. So that's the apothem. That's the perimeter. Now all I have to do is actually multiply these two together and divide it by 2. So area is perimeter times the apothem, and then divided by 2. Now this is an approximation. 120 times 18.1, enter, divided by 2, I get approximately 1086. So the area of all of this is 1086, approximately, plus or minus 0.01 or 2 or something. All right, thank you guys for listening. Make sure you guys do your journal, and your journal is on for your extra practice. Starts on page 327. That's this right here, page 327, and continues on page 328. Okay, have a good day, guys.